humans and future AI overlords. I'm using Google Bard in Safari, and we're all exploring this new world of artificial intelligence and these amazing new tools that we have. I've wanted to learn more about some of the core concepts behind artificial intelligence. So today I would like to understand more about computer vision. So the first question I'm going to ask is, explain computer vision to me like I'm a 5-year-old.
Sure, I can explain computer vision to you like you are a 5-year-old child. Computer vision is a way for computers to see. It's like when you look at a picture and you can tell what's in it, like a cat or a dog or a car. Computers can't do that yet, but they're getting better. Computer vision works by taking a picture and breaking it down into tiny pieces. The computer looks at each piece and tries to figure out what it is. It does this by comparing the pieces to other pieces that it's seen before. The more pieces the computer sees, the better it gets at figuring out what things are. That's why computers that are used for computer vision need to see a lot of pictures. Computer vision is used in a lot of different things. It's used in self-driving cars, so they can see the road and other cars. It's also used in facial recognition software, so computers can tell who you are. Computer vision is a really cool technology. It's not perfect yet, but it's getting better all the time. And who knows, maybe one day computers will be able to see as well as we can. Here's an analogy that might help you understand computer vision. Imagine you have a big box of Legos. You can build all sorts of things with Legos, but you need to know what the pieces are before you can start building. Computer vision is like that. The computer needs to know what the pieces of a picture are before it can start figuring out what's in the picture. And the more pictures the computer sees, the more pieces it knows, and the better it gets at figuring out what's in the pictures. I hope this helps.
That definitely helps. It's kind of what I thought, but explained better. It's interesting how the tool really references Legos, but I think that's such an excellent concept. It's such a perfect reference point, particularly for for children and even adults, of how to construct things, how things connect, how you put things back together. Let's move to the next level. I'm going to ask, explain computer vision to me like I'm a college student.
Sure, I can explain computer vision to you like you are a college student. Computer vision is a field of artificial intelligence, AI, that gives computers the ability to see and understand the world around them. This is done by analyzing digital images or videos and extracting meaningful information from them. Computer vision is a vast field with many different applications. Some of the most common applications include object detection. This is the ability to identify objects in a scene. For example, a computer vision system could be used to detect cars, people, or animals in a video. Object tracking. This is the ability to follow the movements of an object over time. For example, a computer vision system could be used to track the movement of a person in a crowd. Scene understanding. This is the ability to understand the context of a scene. For example, a computer vision system could be used to understand that a person is sitting at a table eating a meal. Face recognition. This is the ability to identify a person from their face. For example, a computer vision system could be used to unlock a phone with facial recognition. Computer vision is a rapidly growing field with many exciting new applications. As the technology continues to improve, we can expect to see even more innovative uses for computer vision in the future. Here are some of the challenges in computer vision. Variation in lighting. The same object can look very different under different lighting conditions. This can make it difficult for computer vision systems to identify objects reliably. Occlusion. Objects can be partially or completely obscured by other objects. This can also make it difficult for computer vision systems to identify objects. Deformation. Objects can be deformed or distorted. This can also make it difficult for computer vision systems to identify objects. Despite these challenges, computer vision is a powerful technology with many potential applications. As the technology continues to improve, we can expect to see even more innovative uses for computer vision in the future. I hope this helps.
Yes, this definitely helps. I liked how it broke down object detection, object tracking, scene understanding, face recognition. These are all concepts that we know about, and it brings to mind some of like spy thriller movies and some security cameras that can be used to deal with fraud and loss in locations and stuff like that. So this is really, I mean, this is really exciting. I feel like the challenges, I love how it brought up the challenges, variation in lighting, occlusion, deformation. I think I think that's excellent. And it's amazing to see how this technology is being applied, like with Magic Eraser, or the ability to, take a picture and then shift it, or move objects around in it, and it can redraw the image. So, and I know Google has done some amazing stuff in that with how we can modify pictures on our phones today, which is incredible. I know that they've done some training data. There was an example of they were trying to identify fish, and they were showing people catching fish, and they were holding the fish up in the image. And the training data was pictures of people holding fish. Now they were identifying the fish, but over time they started to draw the fingertips in the fish that people had holding the fish because it thought it was part of the fish. I thought that was such an interesting reference that these systems, while they become more intelligent and smarter, if you teach them something, they can have clearly a complete misunderstanding of what, the fingertips of the hands holding the fish is not part of the fish, but it doesn't know any better. So it's interesting. It's going to be interesting to see how this evolves even further. So let's take this up another level. Explain computer vision to me like I'm an expert in computer science.
Sure, I can explain computer vision to you like you are an expert in computer science. Computer vision is a field of computer science that deals with the extraction of meaningful information from digital images or videos. This information can be used to perform a variety of tasks, such as object detection, scene understanding, and facial recognition. Computer vision is a challenging field because it requires the computer to understand the physical world in the same way that humans do. This is a difficult task because the physical world is complex and constantly changing. However, computer vision has made significant progress in recent years. This is due in part to the development of powerful machine learning algorithms that can be used to train computer vision systems. Some of the most common computer vision tasks include object detection. This is the task of identifying objects in an image or video. Object detection is a challenging task because objects can be of different sizes, shapes, and colors. Scene understanding. This is the task of understanding the context of a scene. Scene understanding requires the computer to understand the relationships between objects in a scene. Facial recognition. This is the task of identifying a person from their face. Facial recognition is a challenging task because faces can be obscured by hair, glasses, or other objects. Computer vision is a rapidly growing field with many exciting new applications. As the technology continues to improve, we can expect to see even more innovative uses for computer vision in the future. Here are some of the main challenges in computer vision. Variation in lighting. The same object can look very different under different lighting conditions. This can make it difficult for computer vision systems to identify objects reliably. Occlusion. Objects can be partially or completely obscured by other objects. This can also make it difficult for computer vision systems to identify objects. Deformation. Objects can be deformed or distorted. This can also make it difficult for computer vision systems to identify objects. Despite these challenges, computer vision is a powerful technology with many potential applications. As the technology continues to improve, we can expect to see even more innovative uses for computer vision in the future. Here are some of the most common techniques used in computer vision. Image processing. This is the process of transforming images in order to make them easier to analyze. Image processing techniques include filtering, edge detection, and segmentation. Machine learning. This is the use of statistical techniques to train computer vision systems. Machine learning techniques include supervised learning, unsupervised learning, and reinforcement learning. Deep learning. This is a type of machine learning that uses artificial neural networks to learn from data. Deep learning has been very successful in computer vision tasks, such as object detection and scene understanding. I hope this explanation is helpful. Please let me know if you have any other questions.
This was definitely helpful. The response here feels very similar to the previous one when I asked at the college student level. There were some additional content here added towards the end around the techniques using computer vision, image processing, machine learning, deep learning. So I like how it is consistent in its description, and it is also referencing other AI concepts that kind of bring it all together. So it's very exciting. I know I learned something new today. I hope you did too. Have a great day.